Hi guys, this is AAT section 1.2 notes, and we are working on graphing linear functions. This should be a total review from Algebra 1 and Algebra 2, so we're going to go through it pretty quick. A linear function is an algebraic equation whose graph is a straight line, or just a line. All lines are straight, with unique values for their slope and y-intercept. The slope, also known as the gradient of a linear function, describes the steepness of the graph. So how steep the line goes, this way, flatter, is the slope. The y-intercept is the point at which the graph crosses the y-axis and the value of the function where y is 0. So no matter what function you're talking about, y-intercept is always not where y is 0, that's a typo, where x is 0. Please fix that in your notes. Okay, so first of all, you already know that the slope-intercept form of a line is y equals mx plus b, where m, the number comes in front of x, is the slope, and b is the y-intercept. So using that, we would really be able to graph this line very easily. But I want to go back to early pre-algebra, Algebra 1, and remind you, because some of us have forgotten, that a linear function is just all the points that make up a line. If I pick any 3 points, or I could pick 4 points or 10 points, it doesn't matter, any points for x that I want to, so I'm going to pick some easy ones, 0, 1, and -1, and I plug them in for x in the equation, they should line up to be a line. So if I plug in 0 for x, I'm getting y equals 6. If I plug in 1 for x, I get -3 plus 6, I get 3. And if I plug in -1 for x, I get 3 plus 6, which is 9. So if I plot those points, 0, 6, 1, 5, 6, 1, 3, 1, 2, 3, and -1, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, I should end up with a line. Always try to use a ruler or the straight edge. You can use the side of your phone if you want to, but to get a nice line with arrows on the end, because lines, we know from geometry, go on forever and ever. So I could plug in any point. I could plug in a fraction. Any point on that equation would end up on this line. Now, if we had used y equals mx plus b, you know we would have started at the y-intercept is 1, 2, 3, 4, 5, 6, and then we'd use that slope and rise 3, run back 1 to get a second point. We'll do that some more later. Okay, a linear equation is an equation in x and y. You can have no exponents, meaning to the second, x to the third, x to the fourth, x to the fifth. You can't have any square roots of x or fractional exponents, x to the 1/3, x to the 2/3, or things like that. You can't have x in the denominator, which is the same thing as negative exponents. Can't have anything like that. So an equation is linear if it's an equation in x and y, and x and y are called linear terms, meaning they don't have any exponents other than x to the first or to the 0. So is this a linear equation? Yes, indeed it is. Is this a linear equation? No, definitely not, because that x is squared. So sometimes you're just going to have to tell whether or not it's a linear equation. Determine whether each table represents a linear equation. Well, if something is a linear equation, then the slope has to be consistent. And the slope, we know, is subtracting the y's over subtracting the x's. So if I start right here, 8 minus 4 is 4. 1 minus 0 is 1. So the slope appears to be 4, the change in the y's, over 1. Here, change is 4, change is 1. That looks good. Here, change is 4, and change is 1. So this has a consistent slope. So yes, it is a linear equation as long as it's rising the same over and over and over again as you go from one point to the next. Even if we skipped a point, if we went from 4 to 12, that's a total of 8, and 0 to 2 is a total of 2, and 8 over 2 is also 4. Okay, so let's look at this one. Here, 5 to 8 goes 3 or negative 3, depending on if you're subtracting which way you're going. From 8 to 14 is 6. Still might work as long as it's 6 over 2 is the same thing as 3 over 1, so this is 1. So the slope here is 3 over 1, but here from 2 to 4 is 6 over 2, because 2 to 4 is 2. So 6 over 2 is still 3. That looks good. From 14 to 17 is 3, and 4 to 5 is 1, so 3 over 1 is also 3. Since these all equal 3, then this is good, and yes, this is a linear equation as well. All right. So here's our slope equation again. Rise over run, change in y over change in x. Remember, this little triangle here means change in. You see that in science, and we've seen it before in math. Or we could write it as if subtracting the y's over subtracting the x's. So take a second using those formulas, and you can really quick pause right here and see if you can find example 2, the slopes for A and B. Okay, and the answer for A is 1. You get negative 2 minus a negative 12 over 15 minus 5, which is 10 over 10. Be careful with your signs. And for this one, 6 minus 21, y minus y, 14 minus 14 is negative 15 over 0. Be careful when there's 0 on the bottom. That is no slope, also known as undefined. No slope, undefined line would end up being x equals a number, so the equation is going to be x equals 14. I can tell that because they have an equal x value. So no slope if you have 0 on the bottom. The slope is 0 if there's a 0 on the top. Okay, and that brings us to, we learned in Algebra 1, a horizontal line has a 0 slope and its equation is y equals a number. So if the slope is 0, let's look at this line right here. Kind of hard to see, but this y is always 1, 2, 3. It has the point 0, 3, it has the point 1, 3, 2, 3, 3, 3, 5, 3, negative 5, 3. So y is always 3. It's a horizontal line. The slope is 0. The slope is 0 because it is running, but is not rising. So if you do the rise over the run, there's no rise, only running, which is 0 when you get 0 on top, 0 over any number. Okay, a vertical line, we learned in algebra, vertical line has an undefined slope, and the equation is x equals a number. So there's my vertical line over here. This equation, x is always 2. It goes through the points 2, 0, 2, negative 2, 2, 100, 2, 4, and so forth. Every point, x is always 2. It's an undefined slope because it is rising, but it never runs. So that's no slope. Be careful, it's also called no slope as well as undefined slope, because you can't divide by 0. Okay, here, remember, if you have a line that rises to the right, it's going to be a positive slope. If it falls to the left, it's a negative slope. So if I want to find the slope of line A, which is over here, if I just take any 2 points, this is going to go down 1 over 1, down 1 over 1, down 1 over 1. So down negative 1, running positive 1. Negative 1 over 1, which is negative 1. The y-intercept appears to be 0. And we should write that as a coordinate, 0, 0, where it crosses the y-axis. For line B, pause here for B and C, find the slope and the y-intercept, and then check and make sure you get them right. whoops, that's a vertical line. Excuse me, the horizontal line, ahoy, it has a 0 slope because we are running and running and running and never rising, and the y-intercept appears to be 1, 2, 3, 4, 5. Right, that is a coordinate 0, 5. Okay, we're going to stop right there and we're going to come back to this next part.